Good day everyone. So this will be our final presentation of our case study entitled the BMI prediction. So the presentation will be conducted by Mr. Tandoc, me, Mr. Obeña, and lastly Mr. Toragos. So what is BMI? So BMI is the body mass index. Is a number calculated from a person weight and height. So the BMI is calculated by dividing the body mass by the square of the body uh, height and is given in kilogram per square meter. So kilogram over m squared. So the BMI is used as an indicator of the relative healthiness of a person. So the Center of Disease Control, also known as the CDC, and the World Health Organization, also known as the WHO, recognize that people who are overweight or underweight are at higher risk for certain health condition. So BMI also enable health professionals to discuss body weight objectively with their patients. Uh, so next here is the overview of the website. So in order to use our website, you just need to input the height in centimeter, the weight by kilogram, and select the gender. After that, if you generate the BMI, you can see the category of your uh, health condition. So for further explanation of the website, Mr. Tandoc will explain it later. So next here is how to get the BMI. So there are two types of getting the BMI, which is the metric units and the UK units, US. So in our case, we choose the metric units. So this is the original uh, so solution for for metric units, and our data that we get is use centimeter. So what we do here is weight over centimeter divided by 100 to get the meters in the centimeters, then raised by 2. So the polynomial regression is the machine learning that we use here, meaning that you cannot see the exact solution, or the way that we use the solving of this one in our code or in our website, since it predicts precisely according to the according to the data that we use here. So this is the BMI classification. So there are 6 category here, which is the first, morbid underweight, second is underweight, the third one is health weight, the fourth one is overweight, the fifth one is obesity, and lastly the morbid obesity. So the classification of the BMI is where you can see if you're still an healthy person or at risk one. So at the center, this will be the quiet healthy one, but the last two and the first two would be the quite risky health condition. So lastly is the dataset that been used, which is we use here the BMI.CSV. So this is only the partial data that we get in the site. So as you can see here, there are the height, and also the gender, and also the index. And lastly, the gender classification, which is 1 is considered as male and 0 is considered as female. And lastly, the classification of each data, which is, as you can see here, the first one is obesity, the second one is healthy weight, so so and foremost. So for the next presenter, Mr. Toragos will explain more further the coding of our project.
For our project containing these files, including BMI app under BMI underscore .py, BMI underscore model .py, and also our datasets BMI.csv. And for BMI underscore model .py containing these libraries needed for our deployment. Aside from our machine model, we also added some adding columns and rows for our dataset for data visualization that will be displayed on our website. So for our model, first we create a column containing these arrows. For every gender that is equal to female, the gender class will be added 0. And for the gender that equal for male, the gender class will be added 1 for every rows. And then for the classifications, for every index that is equal to 0, the classification will be the morbid underweight. And then underweight if the index is 1, and 2 if the index is if the index is 2, the healthy weight will be added on the row for classification column. And then overweight, also the obesity, and then morbid obesity. As for the index 5 in the classification column will be added for the data set, as you can see here on our data set, the class and the classification, gender class in the classification columns. For our x and y, the x is the independent variable and y for the dependent variable, we will be height, weight, and gender class. Our dependent variable will be the index. For the polynomial features, we added 3 here for the use of controls of features added in the. We will be training these 3 variables here for the for our linear regression, which we'll be using for the BMI up_up.py later. And then for this job leg dump and then linear regression, the system will be creating the file named that BMI underscore model.pkl, and also for the BMI, which is our dataset with added these columns and rows, will be added in the BMI underscore data the underscore model.pkl. And then once we loaded this on the our notebook here, to load these files .pkl extensions, which is centralizing the data and then decentralize it for the program runtime. As you can see here on the pkl 6 minutes ago, and then we gonna load it here. Then for this directory here, as you can see, seconds ago, these 2 pkl extension files were created. And then we're going on the BMI app.py. The content of this will be the process inside our web application. Firstly, for the header here, it's not belong on the sidebar, because with this sidebar, all the contents for the sidebar will belong on this code. The input of height, weight, and select gender, and also the button generate BMI. So first, joblab data. To load the data, we'll be calling the BMI variables with joblab.load, and then the file name and also the file extension. That's our dataset. And then the header, the height, using Streamlit libraries, we can now use the st dot number input for the inputs of height, and also will be inputting the weight variables of the user. And then gender, we have Streamlit select box to select the gender. This is the option that will be shown on the web application. If the button is selected, all the indent under the if button will be processed, will be initialized. The while here, while the button is selected, and will be have a break here to not continue in processing the data, to not continue in processing the program. By calling our model, we use the lin_reg for the variables of linear regression, calling the name and also the file extension. For this select box, every time that the user select male, the gender will be equal to 0, and male has a gender value of 1, because our model here, on our model, the gender class will be accept only integer input, and we have to make this to determine which one and which 0 and which one the gender on the gender class. And then to get the prediction, first we have this polynomial feature degree 3, the number of control feature, and to test all the inputs that we have for scaling. And also for BMI underscore result will be the result of our regression, of our prediction, which is we have this input, the user input height, weight, gender underscore value. And then for considering that the BMI result here is the collection of decimals value, which our index is not decimal value, it's a whole integer. So to do that, the result of BMI underscore result will be rounded and getting the whole value, the integers. And considering that it's in array, we have to get the value. As you can see here, the 1 is still in the array. To get the 1, the value inside this array, we have to get the index, which means it's 0, 1, and 2. And then the index 1 here is the 1, and then 1, and the index 1. So every time that it has a value of 1, we will be using it for our data set to determine the classification of the BMI prediction. Next one, if the index is negative, we will be getting the negative sign, and then returning this error value, and then breaking. If the index is positive, we're going through here, getting the value of the index underscore result into int to get the integer value. And then getting the integer value, we will be getting the classification. For the cat here is the concatenating value of every index that has the index, which is, like for example, here we output the value of cat. All the value that has a 2 integer will be gathering on cat variable. And then the code here in line 66 test underscore list will be listing all the same value, which is having the only one value in the test list. Okay. Getting only the string inside the array will be again using this code. String concatenating of the collection of these concatenating values will be getting the value and join into the item for every item in the list test. And then we will now get the string count. As you can see here, we have the healthy weight. And then for every time that we have a string cut that is equal to morbid weight, we have BMI below 16.5 and the progress bar of 17, and so on, as you can see here. For our graphs that will be showing on this website, first we have the select box that has an option of BMI classification and gender. When the user select any of these options, will be run this code. For the BMI classification, we have the chart using Seaborn as SNS. We have this count plot and the data coming from our dataset BMI. This dash equals false is to prevent the size of the bar graph. If we remove this, our bar graph is so much thin. Yeah, as you can see here, the bar graph here is much more thinner. And then we go pasting it again. The index is our x variable here for the graph, x label, and the u is the classifications. For the orders of the classifications, we input all the classifications on the u orders. plt.legend, the location is on the upper right, as you can see on the graph. And then for the better visualizations of our graph, we remove the chart, the x label, because we only have to display the classifications, not the index of the x labels. The for loop here is to display the labels of the count. On the morbid underweight, we have 13 counts out of 500 respondents, and the highest is the 200, and our morbid obesity has a count of 198. And then printing the graph using the figure, st.pyplot the figure. The figure here is the size of our graph. It has a width of 7 and a height of 3. And we have the count plot, the BMI, which our data set, and the X is the classifications, and the U is our gender, is the respondent's gender. As you can see on the graph, we have the classification in the U for the genders. As you can see on the graph, we have the U of gender. The X here is the classifications, while the Y is the count. And then below the graph, we display our data set, which is the BMI. And that's all for our BMI prediction with the help of linear regression model.
Okay, now, so let's move on the walkthrough of our project. So first, open your CMD. Type in the location, file location of your website, or where the BMI app is located is. So after doing that, activate the environment. Uh, so after doing that, you can now run the BMI app. So let's just wait for a couple of seconds. Okay, so now uh, the BM app uh, BMI app is running successfully. So let's move on the website that we open. So this is our output or final product of our project. We can see forms where you can put input in your height, weight, gender, and to generate BMI. This also includes two graphs, which is BMI classification and gender. So let's try putting some input in it. So let's try 165 centimeters for into 50 kilogram male generate BMI. So this one is considered as underweight. So everything below 18.5 is considered underweight. So now let's try 80 into 160, then female. This one now is considered as obese. So everything BMI that is equal or greater than 30 is considered obese. So now let's try again. Another 150 into 40 generate BMI. So this one is underweight again. Let's try another one. 30. This one now is considered as morbid underweight. So BMI below 16.5 is considered as morbid underweight. So now let's try 169 to 58 male generate. So now this one, the BMI of this input is considered as healthy. The BMI between 18.5 and 24.9 is considered as healthy. So now let's try to put something like more than maybe 100 generate. Still considered as obese. Let's try 140. Okay, now this one is considered as morbid obesity. So BMI greater than or equal to 40 is considered as morbid obesity. So let's try again 20, male or female. Okay, now so this one, the input is height and weight have invalid result for BMI prediction. Please try again. So the meaning of this is that the prediction of the system is negative, but the only index we have on our dataset is 0, 1, 2, 3, 4, 5. So if the prediction neg- uh, is not is not 0, 1, 3, or and so on, that means it is negative. So the output is height and weight have invalid result for BMI prediction. Please try again. So now let's move on the graph. So for BMI classification, we can see how many respondents are in specific classification, such as 13 out of 500 respondents are morbid underweight, while 22 for underweight, 69 for healthy weight, 68 overweight, 130 for obesity, and 198 for morbid obesity. So now let's move on the gender. So in this one, the graph is comparing the male and female under a specific classification. So on this one, we can see that there are more male than female in the classification of morbid obesity. While in obesity, there are more female than male. And on the healthy weight, there are more female that are healthy while 28 on male. On this one, overweight, there are more female that are classified as overweight than male. On underweight, there are 15 male that are classified as underweight, while there are only 7 female. And lastly, on the morbid underweight, there's only 6 male and 7 female. So that's all for the walkthrough of our project. Thank you for listening.